Today's episode dives into three very different frontiers of AI. Agents that can tackle real-world web tasks on live production sites, reasoning models that improve only when we rethink how they are trained, and systems that let skills evolve collectively across users. Together, these papers reveal a common theme. AI is moving beyond isolated benchmarks toward more adaptive, procedural intelligence. But with stronger capability comes tougher questions about safety, transfer, and reliability in the real world. Let's explore the first paper. Clawbench: Can AI Agents Complete Everyday Online Tasks? Clawbench introduces a live web benchmark for consequential everyday online tasks that existing sandbox suites do not capture. It contains 153 tasks across 144 production websites and 15 life categories, with write-heavy workflows such as purchases, reservations, and job applications. The key technical contribution is a safety mechanism that preserves ecological validity. A Chrome extension plus CDP instrumentation records browser activity and intercepts only the final terminal HTTP request, preventing any real-world side effect, while allowing the agent to interact with the live site normally. Each run is logged in 5 synchronized layers: session replay, per-step screenshots, HTTP traffic, agent messages, and low-level browser actions. Human annotators complete every task under the same setup, producing ground truth trajectories and request payloads for step-level comparison. Evaluation is performed by an agentic evaluator, implemented with a Claude Code sub-agent under a fixed rubric, which aligns agent and human trajectories and outputs a binary pass fail verdict with structured justification grounded in schema-level evidence rather than final state similarity. On 7 frontier models, performance collapses relative to established benchmarks like OS World and Web Arena Claude Sonnet 4.6, which scores roughly 65–75% on those suites, reaches only 33.3% on Clawbench. GLM 5 scores 24.2%, Gemini 3 Flash 19%, Claude Haiku 4.5 18.3%, GPT 5.4 6.5%, Gemini 3.1, Flashlight 3.3, and Kimi 2.0.7. The main finding is that current agents remain far from reliable, general-purpose web assistants when tasks require live, dynamic, write-heavy interaction on production platforms. Let's explore the second paper, Rethinking Generalization in Reasoning (SFT), a conditional analysis on optimization, data, and model capability. This paper overturns the blanket claim that reasoning SFT memorizes while RL generalizes by showing that cross-domain transfer from long chain of thought SFT is conditional, not intrinsic. Using pre-trained Qwen 314B base, Qwen 38B base, Qwen 2, 5, and intern LM 2, 520B base, trained on 20,480 verified long COTI math traces from OpenR, 1math220K with math verify, the authors report a consistent dip and recovery dynamic. OOD performance on LiveCode Bench v2, GPQA Diamond, MMLU Pro, IF eval, and Alpaca eval 2 often degrades early, then recovers and exceeds the base model after sufficient optimization. With Qwen 314B base, one epoch training reproduces prior weak transfer results, but extending training to 8 epochs yields large gains, including plus 29.7 points on AIM-24, plus 12.7 on Math 500, plus 7.5 on GPQAD, and plus 21.3 on IF Evil relative to the base at the reported checkpoint. The paper identifies response length as a diagnostic. Early checkpoints produce very long, shallow thinking traces, whereas later checkpoints shorten outputs as the model learns transferable procedures like decomposition, verification, and backtracking. Data quality and structure are decisive. Math, no-code, 20K preserves many benefits. Numina Math, 20K often degrades across benchmarks. And even Countdown, Code 20K, a toy arithmetic game, improves reasoning transfer on strong models, indicating that procedural patterns generalize better than domain content. Capability is the third axis. Quinn 3.1.4b generalizes substantially better than Quinn 3.1.7b, which mostly imitates verbosity and loops. Generalization is asymmetric, however, because long-caught SFT sharply worsens safety on hex PHI via self-rationalization and self-jailbreaking, showing that reasoning gains come with measurable alignment costs. Let's explore the third paper. SkillClaw lets skills evolve collectively with Agentic Evolver. SkillClaw proposes a centralized, closed-loop mechanism for multi-user agent self-improvement that turns ordinary interaction trajectories into shared evidence for skill evolution. The core novelty is an autonomous agentic evolver that processes cross-user session traces, groups them by reference skill, and then edits the shared skill repository by choosing among three actions: refine an existing skill, create a new one, or skip when evidence is weak. Unlike memory-based retrieval systems such as Reflection, Expel, or Reasoning Bank, and unlike static skill libraries, SkillClaw explicitly synchronizes validated updates back to all deployed agents, so improvements discovered by one user propagate system-wide. The system preserves full causal trajectories, including prompt, tool calls, intermediate feedback, and final response, because many failures are procedural and invisible in the final answer. It then runs nightly validation in real execution environments, accepting only updates that outperform the current deployed skill, which enforces monotonic deployment rather than risky online replacement. The paper evaluates this on WildClaw Bench, a 6.0 task benchmark spanning 6 domains with full Linux execution, multimodal inputs, and 327 aggregated metrics per task. Using Quinn 3, Max as the backbone in a simulated 8-user, 6-day deployment loop, SkillClaw improves daytime performance from day 1 to day 6 by plus 6.33 points on social interaction, plus 11.82 on search and retrieval, plus 10.23 on creative synthesis, and plus 8 on safety and alignment. A control validation on 3 diagnostic queries shows a mean gain from 30.4% to 72.5% after one evolution round, including 28.3%, 100% on save report. The strongest gains come from encoding procedural fixes such as API port correction, full message retrieval, first affiliation, disambiguation, and environment-aware pre-flight checks. That's a wrap on today's AI paper highlights. Thanks for watching.